Wide-gamut displays are very efficient and attractive, but they can change our perception through adaptation mechanisms. This effect is not drastic, but it can be long-lasting, and so it is of particular concern when it comes to children. So, why do these changes happen? In natural circumstances, light and all colors that we see are always a mixture of many frequencies, and this basically limits the purity of colors that we can ever see. But relative to the complexity of the whole spectrum, our color vision is fairly simplistic and therefore can be modeled with just three components: red, green, and blue. Each of these colors have their representative frequencies, and the more exclusively a light source can trigger one component and not the others, the more clearly it will result in the perception of that particular color. This process becomes more efficient when we can use narrower bandwidths, so like with wide-gamut displays. If you think about it, this is truly miraculous. Through the development of technology, we can now create a superstimulus. We can see colors that none of our ancestors ever had the chance to see. And with a wide-gamut display, the combination of individually red, green, and blue narrowband sources results in the possibility of creating a large number of very vibrant and unnaturally saturated colors. So everybody wants these displays because their color performance looks great on paper, and it looks absolutely stunning in real life. So in a showroom with many displays, the one with the highest saturation and contrast will always stand out. But what happens when we keep looking at such displays for several hours every day? Our perceptual system adjusts the baseline to this new stimulus, and so the super vibrant colors will become the new norm. They will stop looking so vivid, and instead the rest of the world will start to appear more washed out. It's a bit like energy drinks or fast food. It overstimulates, resulting in both addictions and negative long-term consequences. This is also connected to the fact that the color rendering performance of displays would never be considered acceptable if we would measure them by the same standards as we measure general light sources. So, is it a good idea to look at that weird light through the whole day? On top of that, high color contrast can be uncomfortable for many, resulting in an increased likelihood of headaches and glare. So basically, the constant overstimulation is tiring for the brain. These effects are generally small and certainly nothing to fear. I just brought them up because, relative to how many people are affected, there's very little discussion around this topic. So, wide-gamut displays are wonderful for many applications because of their high performance, but they may also come with some drawbacks. Color adaptation is just one of these. There are also further perceptual and physiological negative consequences of the highly unnatural spectra of modern displays. I'll keep summarizing these, but meanwhile you can read further at Pixan's references page, and I thank you for your attention.